This video is about solving linear inequalities. An inequality is like an equation, except for that instead of an equal sign, there's either a less than or a greater than sign. So we need to make sure that you know these two symbols. This symbol means less than. You read it as less than when you go from left to right. And this symbol means greater than when you read it from left to right. So you may have an expression, or an inequality, I should call it, like this. X is greater than 4. What this means is x has the values, all values, greater than 4, like 4.5, 5, 6, 7, 7.5, any value greater than 4. There are also two more symbols that look very similar that mean the same thing or equal to. So it's a less than symbol with a straight line underneath it, greater than symbol with a straight line underneath it. These mean less than or equal to, greater than or equal to. So you may have an inequality like this, and you would read this as x is less than or equal to -2, which means x can take the values anything less than -2, like -10 or -1,000, all the way up to and including -2. So this time x is also allowed to equal -2 itself. So x takes the values of -2 and below, as opposed to the previous example where x only was values greater than 4 and not 4 itself. The solution of an inequality is any value that makes it a true statement. To graph a solution set, we have our first example, x is less than or equal to 3. We draw little number lines so we can get a visual representation of all of the possible answers for x. It's helpful to put 0 somewhere on your number line so everything is relative to 0. Which puts the number 3 over here. Notice I'm not labeling every single mark on this number line, just the ones between 0 and the number I'm trying to find. And here, x is less than or equal to 3. So I need to shade in all the possible values for x on this number line. There are many ways to show it. I'm going to show it just a little bit above the number line so it's easier to see. So just a little bit above the number line, I'm going to shade in the number 3, because x is allowed to equal 3 in this example. And I also want to shade in all of the values that are less than that. But rather than putting a bunch of circles going all the way down, I'm just going to draw it as one shaded bold line, starting from my point and going all the way down to -infinity, because x includes all of the values less than or equal to 3, including the ones between the numbers, like 1/2 and -4.5. So I just use a nice bolded line going in that direction to show x is everything I just shaded in red. So the next example, what happens when it's just greater than without the equal sign? So I'm going to put 0 somewhere on my number line, so that -1 is located in the right place relative to that 0. This time x is greater than -1, but doesn't include -1 itself. So I don't want to include the -1, but I do want to start from the -1. In order to show that, I put what's called an open circle at -1, and then I shade the numbers that are greater than that using one of these nice dark lines, greater than -1. And what this shows on the picture is that x starts from -1 but doesn't include that -1. So I have an open circle there to indicate that it's not shaded right at that point, but it is shaded everywhere above it, including the numbers that are between -1 and 0, right? Those numbers are shaded. So that's why we can't just start it at the next number. So start it at the -1 with an open circle. So we're going to use a closed circle if there's an equal to sign, and open circle when there's not. A compound inequality consists of two simple inequalities that are joined by an and or an or. Now when we have an and, like in this first example, you don't actually see the word and in here anywhere. But it's a compound inequality because you're showing me that x is two things. X is above -1 and it's below 3. So x is in a sandwich between -1 and 3. If I was to graph this on a number line, I want to put both endpoints up there, so -1 and 3. And because neither one of these inequality symbols has the equal sign, I'm going to use two open circles at -1 and 3. And I'm going to shade that x is everything in between them, greater than -1 and less than 3. So x can only take a specific value that is both greater than -1 and less than 3. For example, 2. In the second example, I have x is less than or equal to -1, or x is greater than 4. But x can only take a single value, so it has to meet either the qualification of being less than or equal to -1 or of being greater than 4. So if I put 0 on here, 1, 2, 3, 4, negative 1, I'm going to have one closed circle because x is allowed to equal negative 1 or below, right, less than or equal to negative 1. Then I'm going to put one open circle because x could also be a value that is greater than 4, but not equal to 4. You may have to solve an inequality or isolate the variable. That's what solving means, right? To graph it on the number line. So you have to solve first. And it's the same as solving equations with one additional rule, which is that you have to flip the inequality sign. And the inequality sign means these. You have to flip the direction if you're going to multiply or divide both sides by a negative. So I purposely picked an example where this is going to happen so you can see what I'm talking about. If I try to solve, so here's my inequality. You see x is in two different places. I can't graph this on the number line yet because I don't know the single solution for x, right? Is it greater than 7 or less than 2? Or I need to solve the equation first. So I'm going to subtract the 5x from both sides to get the x's both on the left. And when you subtract the 5x from both sides, 3x minus 5x is negative 2x. Bring down the plus 2. So see, I'm solving it just like I would solve an equation. Only instead of an equal sign, I keep that greater than sign. Next step, I want to subtract 2. So nothing fancy yet. I'm just following the rules for solving equations, doing inverse operations to both sides, and then I get to this step. At this step, I have to divide by the negative 2, which is in front of x. So I'm going to divide by negative 2, and the coefficient is negative 2. So I've divided on both sides. And because it's negative, the special rule applies that when you multiply or divide by a negative in an inequality, you have to change the direction of the sign. So these will cancel out, and x will be less than, see how I changed the direction of the sign? Positive 6. And where did I get positive 6 from? Well, I just did this division problem, right? Negative 12 divided by negative 2. The really important thing is that you're remembering to switch the sign so that on your graphical representation of this, you're shading in the right direction. X is going to be, if 0 is here, I have 1, 2, 3, 4, 5, 6. X is going to be an open circle here, shaded less than the 6, because those are the values that when you plug it back into the original inequality will make the statement true. To solve an and inequality, these are the ones that have x in the middle, like in this little sandwich. We want to isolate the variable in the middle. So I'm going to make this a little bit larger, put it in the, oops, I lost it. I wanted to make it larger and put it in the center of the screen for you to hopefully see it a little better. Okay. See, there's an x in between the two inequality signs, and I want to move anything else that's in between outside. So x will be by itself in the middle. This means I need to add the 10 to get it out of here. And just know that you have to add it to all of the sides. It's almost like a three-headed monster, right? We want to add that 10 to all of the sides of this. So on the left, we get a 6. In the middle, the 10s have canceled out, so now I just have 6x. And on the right, I have 24. And then I divide by the coefficient of x, again on all, quote-unquote, three sides of this equation. 6 divided by 6 is 1. X is alone in the middle. 4 on the right. So x is in a sandwich between 1 and 4. It's all of the values between 1 and 4. To solve an or inequality, just solve them both separately as two separate inequalities using all of your rules about solving equations, paying attention in case you ended up dividing by a negative, which there we did not have to divide by a negative, so there was no sign switching that had to happen. So I'm just solving these equations, getting x by itself, and then in the end, sticking the word or in between them, because to graph these on a number line, here's 2, here's 4, of course x is less than 2 or greater than or equal to 4, and those lines have to be shaded in opposite directions from each other. And that is all.